walks 30 meters, then turns a corner and walks 40 meters. It took her 1 minute to do this. What was her average velocity? And I drew a triangle below that. I said might help you. Okay, so why did I say that triangle might help? Why do you think I said that?
Because it's a 3, 4, 5 triangle.
It's a 3, 4, 5, and when you look at what she did kind of the same thing, except instead of 3, 4, 5, she did 30 and 40. So she walked along here for 30 meters, then she walked along here for 40 meters. So that means she walked a distance of 70 meters. And what am I asking? Oh, and the time is 60 seconds. And what am I asking you for? Her average velocity. Okay, so her velocity basically. Right, so who knows how to do this one? What should I do? Average velocity.
Displacement over time.
Displacement over time, yeah. And what is her displacement? Yeah, she's displaced 50 meters and her time is 60 seconds, 1 minute, yeah. Which is 0.84 or something? Something like this, maybe. We could hit 5/6. What's that on the calculator if you have it handy? .83 meters per second. Now this isn't quite the answer. I'm missing something from my answer. What am I missing from my answer? Direction, yeah. Because I wanted the velocity. So I must have a direction. So I'll say at, what's this now? 53.13, yeah. At 53.13 degrees then. So this is the velocity. Yeah. Notice how this is quite different to the speed. The speed would have been 70 meters over 60 seconds, which is, as you can see, definitely not the same. Yeah.
What I got wrong was I did it by kilometer per hour.
Oh, yeah, okay. Do you know, I never actually said meters per second, so I suppose technically, if you did something like that in the exam, it might be okay. Yeah. Okay, so that was number 3. Is number 4 okay? Yeah, number 4 was okay? Yeah, alright, so let's go on to now the next one here. Right, how did we get on with this one? Where was the first difficult one? What was the first one that was a problem?
I had trouble with 4.
4, good, yeah.
And 7.
7 for sure, yeah. Okay, what about over here? You two guys, what do you think? For this one here?
4 and 7.
4 and 7 as well? Anything else? So will I do 4 and 7 then? So 4. Okay. A girl is at the top of a slide, as shown, ready to follow her brother, as shown. She pushes off with a speed of 1 in a horizontal direction. The slide makes an angle of 45 with the floor. With the help of a diagram, resolve the girl's velocity vector into a component which is parallel and perpendicular. Yeah. That is considered the horizontal quotation marks x-axis of the slide. Okay, so what's happening here? You have a slide, and this is the top here, and the girl starts here, and she begins by moving this direction at 2 meters per second. Now, if that's what she begins at, of course she doesn't stay at that, because as she moves down the slide she'll go faster, and also her direction will change. But at the beginning, it's this direction. I want you to resolve this into 2 components, but what's different is, in the lesson, if you were watching the video, I was usually resolving into a direction like this and like this. Let's just see if you remember. If this is theta, and let's call this x, how big is this side? X cos theta, yeah. And this one here? X sine theta. And does anyone catch in the video my trick to remembering which is the cos and which one is the sine? I said in the video there's a way to... How do you know which way around to put them as a shortcut? No? Yeah, that's it. Very good. I said cos is the side that touches the angle. So that's a very, very useful trick to remember. Please remember that. That's very useful to remember. Cos goes on the side that touches the angle. Okay. Now, this here is, I tell you in the question, 45 degrees. And what I'm looking for is the component this way, and then the component this way. If you remember my trick, because this side touches the 45, this is the cos. But in fact, in this question here, it doesn't matter so much, because this side here is also 45, which means this is also cos and this is also sine, because actually cos 45 and sine 45 is the same. So it didn't really matter. This is root 2, and this one here is root 2. So the answer is root 2 meters per second and root 2 meters per second is the answer here.
Is it root 2 or root 2 over 2?
Let me think. I think it's root 2.
It's 1 meter per second that she pushes off it.
Oh! I misread it. Thank you. It's not... Sorry, my bad. Look, this isn't a 2. This should have been a 1, which changes this and this, of course, to 1 and 1, which is what you said. It's now a root 2 over 2 instead. Yeah.
But it's fine if, like, I don't do it on the diagram and stuff. I use the side as x-axis and draw a graph.
Yeah. Oh, I see. Just draw an x and a y. Yeah. Actually, that's fine. I like drawing pictures with stickmen in them. It makes me happy. So that's the only reason. Okay. Shall we have a look at 7 now? Was 5 okay?
Yep.
Yeah, and 6? Okay, good. So 7 now with the 2 blocks. A block M2 slides down a 45 degree wedge at speed of 2, and the wedge is moving away at a speed of 3. By resolving and adding vectors, what is the final magnitude and direction of block M2? Okay, so what's going on here? You've got this block here, and it's moving to the left with a 3. Yeah. And then you've got another block here, and although it looks like it's moving down the face with 2, not only is it moving down the face, but the thing it's on is moving backwards. So this means it's a little bit of a problem, because we don't really know how fast this is going, because it's on a thing which is also moving. So let's begin. We would like to add these 2 vectors together. Now the easiest way to do that is if we can resolve. Now we have a couple of choices here. Imagine I just draw a line here and then a line here. So we could resolve this vector here along this axis and along this axis. And then that way we could add it with this one here, which is already on this axis. But that doesn't feel right, because, well, I guess that would work okay, but it would seem more natural to, rather than go that direction, we should go this direction, that we resolve along these axes. Because this one here will be already done. And this one here, we should now resolve it into a direction which is parallel and perpendicular to this one. And in that way, it's easy to add together. But the problem is we need to figure out the angle here. Well, this angle here I said is 45. Now there's a thing from maths which you might remember from middle school. If I draw a line like this, a line like this, and this is an angle, 45, or whatever it is, then this one here must be the same. And that's actually the picture that you have here, that this one here is the same as that. And because that touches the angle, it makes this one the cos. So this is 2 cos 45, and this one is 2 sine 45. And I know that's a root 2, and that's a root 2. Okay, good. So if we look at our picture now, we have a vector going this way of 3. And then if we look at this one, we have a vector going this way of root 2 and going down with root 2 meters per second. Now we can add them together, and they add together quite nicely. How do I add these two vectors together? If we call this one A and this one B, how would they add together? What numbers do I plus? What do we think?
The x's alone and the y's alone.
Yeah. So here, 3 is bigger than root 2, so it's moving to the left with a 3 minus root 2, and it's moving down with a root 2. Okay? And what did I ask you for? What is the magnitude and direction? Okay, so firstly, let's get the magnitude. That is square root 3 minus root 2 squared plus root 2 squared. What's the name of that theorem? Pythagoras, yeah. Three minus root 2 squared. Oh no. There we go. Squared plus 2.12 meters per second. And the direction, let's call the direction here theta. How do I get the direction here? Tan inverse, yeah. Which and which? Which way around?
The opposite.
Yeah, which is what here? Root 2. Yeah, over 3 minus root 2.
I have a question.
Yeah.
Why did you take the 3 as positive and the square root 2 as the negative?
No, I could have done it the other way around. And it means my answer would be a negative, which means it's to the left. I suppose in my head I wanted this number to be positive to the left, but if you drew it like this to the right, but you got a negative number, like negative whatever, it's the same thing as drawing it to the left but with a positive. Did you do root 2 minus 3? Is that where? Yeah, and you got a negative number, which just means it's pointing to the left anyways. And in fact, it doesn't change the answer here because you square it anyways, so it's fine. It might just mean you have to be extra careful with your angle because now you have a minus in here. That's just to be careful with. What is this here? Shift tan inverse root 2 over 3 minus root 2. 41.7. 41.7 degrees downwards. Pointing down. Yeah?
What if, like, I make, like, the 3 minus root 2, I put it in a way like just the, like, negative square, like negative 3 plus root 2.
Oh yeah, that's the same thing she was asking.
Okay.
Basically, isn't it? The sign's the other way around. So what did that change? That didn't change your magnitude, correct? No. It might have changed your direction though. Your direction might be a negative. It's not a problem to do that. because as I was saying there, if I draw this, that's the same as drawing this. Your minus in your answer is indicating that it's to the left, whereas in my answer, my left is indicated because I drew it to the left with a positive number. In other words, the difference is, it's like you're saying, the man moved right at -2 meters per second, which actually means you moved left, yeah. Whereas what I'm doing is I'm saying the man moved left at 2. So there isn't really a difference. It's just the reason I did it my way is because I try to avoid problems with minus, especially when it comes to calculating angles. I think if I put a minus in here, I get a negative angle.
Yeah.
And now you have to think really carefully about what that
We
means.
should remove the negative, right? If we want to write to the left.
Sometimes yes, sometimes no. You know, so this is what I'm saying. It becomes more complicated now because you have to think very carefully about what did it mean because I got a minus angle. Yeah. So I try when possible to avoid this. Now you said you got this by accident, or was that you? You said it, yeah. You got it by accident. How do you get the answer by accident, by the way?
I drew it like 3 meters per second to the left.
Yeah?
And I drew a diagonal line with 2 meters per second, and I drew a dotted vertical line.
That doesn't sound like by accident. That sounds like the right way.
No, but then I didn't know like why -3. I just assumed that -3, like 2 cosine 45 -3 is due to like the way in the sentence it mentioned that it went away.
Okay. Okay.
So I just assumed that it's a negative.
Well, are you happy now that with how it's done this way? Yeah. Is this one okay now? The resolving vectors, yeah. Yeah, I don't think there's. I don't think there's anything else to say about this. 7 was the hardest. Okay. All right. We'll leave the vector. If you're happy, we can leave the vectors, unless you have questions from the lesson that you watched. Now, if you do have questions, please ask me. Was there anything in the video that you didn't understand?
I didn't watch the video.
My heart. I'm
I
shocked.
did subscribe, but I didn't watch the video.
Oh well. You were able to do the questions without watching the video? I guess that's okay. Where do you live?
Dublin 24.
So you take the bus. So maybe the next time when you're on the bus, you can put the headphones in, you can open up YouTube, and you can just watch the video. Even if you know everything, watching the video, you might learn a trick or two. Like you heard in the video about my trick with the cos theta, yeah. So even if you could do the questions, could you watch the videos? Because you might pick up a couple of tips or tricks. Yes? I'll keep an eye on my view count to make sure it increases by 4. Yes? Okay. We'll continue then, so... okay, next now.